Good morning, dear students. We'll start studying about the mechanism of photochemical smog. Very important. It is a sure question in the environmental pollution. Now, the mechanism of photochemical smog. So, in order to understand the photochemical smog formation, a smog. What is smog? Smog is a mixture of smoke and a fog. Now the oxides of nitrogen and hydrocarbons. So the hydrocarbons, oxides, hydrogen oxides, methane, nitrogen oxides, etc., are let out into the atmosphere from the automobile exhaust. So these all gases are called as flue gases. Now, incomplete combustion of the fossil fuels will let out some of the unburned hydrocarbons along with the oxides of sulfur, carbon, and as well as the nitrogen. Now, in presence of sunlight, these hydrocarbons will undergo a continuous chain reaction, and it will form a very important intermediate that is nothing but peroxyacetyl nitrate. In short, it is called as a PAN, peroxyacetyl nitrate, which is the primary substance for the formation of a photochemical smog. Now, how does this peroxyacetyl formation takes place in the atmosphere? Now, you know that the atmosphere consists of nitrogen oxide and nitrogen, carbon oxides, and an oxygen. Now, in presence of sunlight, so nitrogen combines with an oxygen. It will form a first step. In the first step, nitrogen oxide, nitrogen monoxide, and these nitrogen monoxide, two molecules of nitrogen monoxide will react further with the oxygen, and it will form a nitrogen dioxide. So this the cycle which will be there in the atmosphere. N2 plus O2 give rise to two molecules of NO, and these two molecules of NO will combine again with the oxygen, and it will form a nitrogen dioxide. Now NO2 in presence of sunlight will undergo photodecomposition, and it will releases NO and a nascent oxygen. So this nascent oxygen will combine with the oxygen, and it will form an ozone. So this is the chain of reaction which will be existing in the atmosphere, and hence you get an active intermediate of nitrogen oxide, and then also an active oxygen. Now, in the formation of photochemical smog, and let us say an hydrocarbon is left out into the atmosphere by an incomplete combustion of an fossil fuels or maybe gasoline. So let us say RCH double bond CHR is the simplest hydrocarbon which will be let out. When these will be sent out into the atmosphere without burning, this reacts with the oxygen molecule, and it will form an activated free radicals. Now it will form an carboxy free radical, the first one is, and alkyl free radicals. So it will form an oxy free radical, carboxy free radicals, RC double bond O dot, that is carbon with an oxygen, carboxy free radical, and it will form an RCH2 dot, that is an alkyl free radical. So these will form an free radicals as an active intermediate for the formation of photochemical smog. Now, during the formation of photochemical smog, the first step is the formation of a reactive aldehyde. Now, you know very well from the previous equation, RCH2, alkyl free radical, further reacts with an oxygen, and it will form an RCH2O dot, O2 dot, that is again it will form one more free radical intermediate. Now these two molecules of RCH2O2 dot reacts with NO. You know from previous equation, NO will be formed by the photolytic decomposition of nitrogen dioxide, and it will form RCH2O dot plus NO2. Now this RCH2O dot, two molecules of RCH2 O dot, that is the carboxy free radical, reacts further with the oxygen, and it will form HO2 dot plus RCHO. So very important here is an aldehyde will be formed by a chain reaction of free radicals. From the alkyl free radicals reacts with continuously with the oxygen and the nitrogen monoxide, and it will form an reactive aldehyde. Now in the second step, formation of hydroxy free radical. Now this HO2 dot free radical reacts with the nitrogen oxide which is available, and it will form an hydroxy OH dot plus NO2. So this is also one of the free radical which will form during the reaction between nitrogen oxide. And the third step is reaction of these hydroxy free radical with the aldehyde. So this hydroxy free radical also simultaneously forms in the atmosphere, and the stable aldehyde will be formed in the atmosphere by continuous reaction. Both will react with each other. Now the RCHO reacts with HO dot, and it will form an RC double bond O dot. That is again a carboxy free radical, carbon with an oxygen free radical, and forms a stable water molecule. Now this carboxy free radical is again unstable. It's an unstable free radical. Now this unstable free radical will react with the oxygen again, and it will form an RCO3 free radical. So this RCO3 free radical will react with the fourth step, formation of PAN, peroxyacetyl nitrate. RCO3 free radical, RCO3 dot, reacts with NO, nitrogen oxide, which is already available, and it will form an RC double bond O with oxygen linkage and NO2. So you have a 3 oxygen here, 3 oxygen, and NO2 will be formed, and R will undergo RC double bond. In this compound is nothing but, this compound is called as an peroxyacetyl nitrate. So the peroxyacetyl nitrate will be formed by a chain reaction from the beginning. It will the first step is nitrogen plus oxygen give rise to nitrogen monoxide into a dioxide. Dioxide decomposes, again forms a nitrogen oxide, releases a nascent oxygen, and that when the hydrocarbon released into atmosphere, which will react with an oxygen, and it will form an alkyl free radical and carboxy free radical. That alkyl free radical undergoes continuous reaction, and it will form a peroxyacetyl nitrate. Thank you.